Welcome to part 7 in this series of videos where I create a form using cascading grids. In this video, we'll look at something I'm describing as dynamic dialog. I've called the application Wall Area Calculator, but so far we've done precious little calculating. This is where the groundwork for the calculations start. I mentioned at the very beginning that I wanted to calculate the area for walls in a couple of bathrooms, and that the bathroom walls were odd shapes. Specifically, the roof eaves form part of the ceiling, so some walls are not rectangular. This is an example of the walls shown here, a simple wall and what I'm describing as a complex wall. The way I'm going to calculate the net area required for tiling is to take the gross area and deduct the area for doors and windows. Calculating the gross area for a simple wall is, well, simple, just the height times the length. For a complex wall, calculating the gross area is a little more complicated, but basically quite simple. To calculate the gross area, I'm going to split the wall into two rectangles and a triangle. I will ask the user to provide the values for C, maximum length, A, maximum height, B, minimum length, and D, minimum height. From these we can see that the base area of the triangle is C minus B, and the height F is A minus D. The gross area of the wall is therefore the area of rectangle A times B, plus the area of rectangle B, E times D, plus the area of the triangle C, E times F times a half. As an alternative, I could have calculated the area of the equivalent simple wall, A times B, and subtracted the area of the missing triangle, but I decided to go with the first option. I want the dialog to cater for both simple and complex walls. To achieve this, I propose having a drop-down list at the top of the dialog with three choices: simple, complex left, and complex right. Complex left and complex right are essentially the same as far as calculations are concerned, but it may make it easier for the user to visualize if we have two different diagrams. Depending on the type of wall selected, I want the dialog to react dynamically by displaying a graphic of the type of wall and only requiring the user to enter the essential dimensions for the wall chosen. So the first step is for the user to select the wall type, in this case a simple one. If the user chooses a simple one, a diagram is shown with the wall height and wall length, and the user is requested to enter both wall length and wall height. If a user selects one of the complex wall types, the diagram of the either complex left or complex right is displayed with text boxes that require the user to enter the maximum and minimum wall lengths and the maximum and minimum wall heights. The key part of this design is that depending on the wall type selected, a different diagram is displayed, different text boxes are displayed with different labels, and the height of the dialog adjusted to accommodate one or two row of text boxes. The other subtlety is that I only want the option to select a wall type when adding a wall. I don't want the user to be able to edit a wall and change its type. To create these dialogs, we will need three diagrams. I'm not going into how to create these other than to say that I used a product called Draw.io, a free application. I hadn't used Draw.io before, but found it relatively intuitive. It can either be downloaded as an app or used in a browser. I exported the diagrams into a temporary folder as .jpeg files and called them simple.jpg, complexleft.jpg, and complexright.jpg. When exporting the diagrams, you may need to experiment with export options, zoom, border width, size, and appearance to get the results you require. In my case, I went with zoom equals 100, border width equals 0, size equals diagram, appearance equals light, and my diagrams were about 700 pixels wide and 450 pixels tall. After that introduction, let's have a look at the code. The dialog that we use for recording the wall is on the index page. So open index.razor. And the first thing we're going to do is tackle wall types. These are the simple, complex left and complex right. Now, since we only require 3 wall types, rather than add a wall type table to the database, we can simply declare them in code. And I'm going to do this under the list for the toolbar items. So I'm declaring a class of wall type, which has just got an ID and a name. And then I'm populating that with 3 records, numbered 1 to 3, with names simple, complex left and complex right. I'm declaring wall type to have an ID as well as a name, so that I can order them in the wall type drop-down list in sequence 1 to 3. We'll be using a variable which I'm going to call selected wall type name. So I'm going to insert a declaration for this. Notice that I'm using wall type name rather than selected wall type ID, as the code will be easier to read if I've got selected wall type name. So I'm going to add it under here. So that's simple enough. I'm just declaring a public string of selected wall type name and setting it to an empty string. We will need to distinguish between a user adding a new wall and editing an existing wall. The reason we do this is if they're adding, we will allow them to have a drop-down box to select the wall type. Otherwise, we'll have a text box which is displaying wall type that's already been added for the record. So I'm going to declare a Boolean, and I'm going to call it isAdd. And it doesn't matter again where I put this, so I'm going to put it here. And we can now modify the wall toolbar click handler to set isAdd to true if the user clicks the add button, or false if they choose to edit an existing wall. In the case of add, we can also set the wall type ID to 0 and the wall type name to an empty string. So we'll go to the add section of the wall toolbar handler, and we can put the following code in here. So if it's adding, I'm setting isAdd to true, the selected wall ID to 0, and selected wall type name to an empty string. If it's edit, on the other hand, I'm going to set it isAdd to false. We can now turn our attention to the wall dialog box. After the wall name, we need either a drop-down list for wall types, in the case of adding a new wall, or a text box displaying the wall type if editing an existing wall. So we go up to the dialog. Here we are. And after the wall name, we need to insert this. And what I've got here is a horizontal line. Then if add, I'm showing a drop-down list. It's a wall type string. It's going to be, the label is always going to be shown, so float type is always. The data source is local data, and the placeholder is selector name. But the important thing here is we've got an event. So when it changes, we've got an on change wall type. And it's that will enable us to hide or display the various diagrams. If it's not add, we'll just display a text box called wall type, and that will show the wall type name. This is the drop-down list will show the wall type name, but the value that's going to be recorded is wall type ID. We no longer need the area, so we can delete that section. The area will of course be calculated. We've got this new method on change wall type, so we need to add some code for that. That's pretty straightforward, and I'm going to put it at the top of the walls region. And what that does is, on the change of wall type, the wall add edit object is populated with both the wall type ID and the wall type name. How the rest of the dialog appears will depend on the wall type being added or edited. And to handle the three wall types, we can use the C# switch statement. So we're going to provide some scaffold code for this in the CHSTML section after the if is add section. So let's go back to the top, and we want to put it in here. And it's going to be a little bit verbose to start with. So we're going to say, we're going to use the switch, and we've got these cases: simple, complex left, and complex right. And this is just the scaffold. So this will behave in one of three ways, depending on the value of the wall type name. I could have used the wall type ID here, but the code is going to be much clearer using the name. The code will run through the options until wall type name matches one of the cases, and then executes the code until it reaches a break. We haven't got any code in there for the moment. In all three cases, we want to display the diagram of the relevant wall with the descriptions of the measurements required. Add a new folder under www and call it media. So add folder. And now copy and paste into here the three diagrams that were created using draw.io. So it should have complex left, complex right, and simple. And now we can copy some code into here to handle the display of those diagrams. So that's the simple one. So all I'm doing is having a line break and then an image with the source going to media/simple/jpg. And we've got similar ones for left and right. Now we ought to save the files at this point and run the application. If we add a new wall, I'll call it simple, and we get the diagram of a simple wall there. If I add another one, I should get a diagram of a complex left wall. So that seems to work. We'll now deal with each of the wall types. For the simple wall, we only need the user to provide the wall length and wall height. We will therefore have two numeric text boxes, and to make the layout as visually pleasing as possible, we'll have them on the same row. To put them on the same row, we'll need some CSS formatting. I'm not going to go into this in great detail, but we need to insert the following in the style tag section. I'll put a link in the description and in the accompanying blog post with links to further explanation of how this works. We can now add the numeric text boxes. So for the simple statement, we want this. So it uses that new class called grid container, and in the left-hand column we want a numeric text box, and the placeholder is going to say wall length in millimeters, and we're going to format it with nil decimal places, and we're going to bind it to the wall add edit wall length maximum, although that's not what the description is here. Similarly, on the right hand column, we'll have the wall height, and we'll have that as wall height maximum as well. For the complex wall type, we need the user to input maximum and minimum wall lengths and wall heights. We use the same technique as for the simple type wall, but just add the two numeric text boxes for minimum wall length and height. And I'm going to be doing it in both in exactly the same way. So if we just look at the complex left, we'll have maximum wall length, and that's bound to the wall length maximum. Same with wall length minimum, wall height maximum, and wall height minimum. And I'm doing exactly the same for the complex right. Until these changes, the user entered the wall area in the text box we've just deleted, and default data for wall type ID, wall type name, maximum and minimum wall lengths and heights were set in the wall save method. As we will now be calculating the wall area from the data input by the user, we now need to remove those defaults. We therefore need to go to the wall save method and comment out the section that provided this data. So here in wall save, this is where we provided the data, and we just need to comment that out. We are now saving wall lengths and heights during the add option, but when editing a wall, we need to retrieve this data. The technique we will use is to modify the wall row select handler to capture the data when the user selects a record. The key to this is that when the walls enumerable is populated by the wall service .walls read by room, passing through the selected room ID, it retrieves all columns in the walls object, including the lengths and heights. The wall rows therefore contain all the data we need. To make these changes, we need to do three things. The first is to declare variables to hold the data. The second, to change the wall row select handler to save the data to the new variables, and lastly to populate the dialog with these values when the user selects edit. So we'll start by going to the declarations and declaring the variables we'll need. I don't think it matters where we put them, so we'll put them down here. So we've got integers for selected wall length, maximum, minimum, height, maximum, and minimum. That's stage one. We now need to go to the wall row select handler and set these variables. So this is the data we're getting so far, and now we'll add the code that we need for the other variables we've just added. Those are the variables, and this is just reading the data from the arguments from the wall row select handler. Lastly, we need to change the wall toolbar click handler to populate the wall add edit object with the data that we've just read from the wall row. So we need to go to the wall toolbar click handler. And it's in the edit section here that we need to populate that. So we'll paste in the code we need here. With that, we should be able to add a record, and when editing it, the text box for maximum and minimum wall lengths and heights should be populated. So we'll just try that just to test it. Right, select a project, select a room, and to make sure I'm dealing with clean data, I'll add a room, so I'll add a wall first. Now if I go and edit that wall, we're now populating those text boxes. Excellent. We're finally getting to the stage where we can do the calculation of the wall area. But first, a bit of tidying up. In the Wall Row Select handler and Wall Toolbar Click handler, we are reading and assigning values from and to wall square meters. We no longer need to do this, so we comment out lines that refer to selected wall square meters in these two methods. The first is in here. That's the row we want to comment out, so I'll just comment it out. And I'll just search for wall square meters. And here's the wall row select handler, and again we comment out that line. We'll create a separate method for calculating the area of a wall and call that method where needed. We want the area of the wall in square meters, but the dialog asks for the measurements in millimeters, which is the usual unit of measure used by the construction trade in the UK. This presents a small problem in that the wall length and height types are integers, and we want the final result as a decimal. We therefore need to change the types of these measurements to decimal types. To prepare for this, we'll add some new variables to the declarations, and we'll add those now. I'll put them at the end here. And what I'm doing is having types that are decimal types and then basically all the variables we need as decimals. Now, as I say, we want a separate method to calculate the area, and I'm just going to paste the code we need in at the end and then explain it. We need two different ways of calculating the area, depending on whether the user selected a simple or complex wall. We use the switch command to handle this. Note that complex left and complex right use the same code by placing them on adjacent lines with no break command between them. In both cases, we convert our integer values for wall length and height to decimals to start with. The area for a simple wall is relatively simple. We're using some rounding, but it's simply the wall length maximum times the wall height maximum, and then we're dividing by 1,000,000 to convert from square millimeters to square meters, and we're rounding to 3 decimal places, and we're using midpoint rounding away from zero. I'll explain that in a little more detail later. For complex, it is a little bit more complex, and I'm just going to decrease the magnification so you can see it all, or as much as I can get. First of all, we convert the lengths into decimals, and then we're going to have 3 areas to calculate. And if we refer back to our original diagram, we can see that we've got 3 areas to calculate. The area of rectangle A, then the area of rectangle B, and then the area of triangle C. So A is the first one we do, which is the height maximum times the length minimum. So the height maximum times the length minimum. Area 2 is this area, which is the length maximum minus the length minimum to give the length of the particular rectangle times the height minimum. And lastly, we've got the triangle. And the triangle is the length maximum minus the length minimum times the height maximum minus the height minimum divided by 2. Again, we're rounding to 3 decimal places. And then we're going to add the square meter to the wall add edit object. Now let me just explain a little bit about the rounding. In C# there are 4 ways of rounding. We can round decimal, which rounds to a decimal value to the nearest integer. We've got round decimal int32, which rounds a decimal value to the specified number of decimal places. We've got round decimal midpoint rounding, and that rounds a decimal value to an integer using the specified rounding strategy. And lastly, we've got round decimal int32 midpoint rounding, and that rounds to a decimal value to the specified number of decimal places, the precision, using the specified rounding strategy. Now, we want our answer in square meters to be in decimals. So that will immediately count out the first and the third methods, which only round to decimal values. So we're left with either round decimal int32 or round decimal int32 to midpoint rounding. Round decimal int32 rounds a decimal value to the specified number of places. That's the definition. But it uses bankers rounding. And this is a rather strange method, rounds to the nearest even number. For example, when rounded to 2 decimals, 2.354 becomes 2.35. But 2.355, as one would expect, becomes 2.36. And 2.356 becomes 2.36. On the other hand, 2.364 becomes 2.36, as one would expect, but 2.365 becomes 2.36, i.e. it is rounded down to 3.6, whereas this one, 3.55, rounds up, and 2.366 becomes 2.37. So that's the round decimal int32. Round decimal int32 midpoint rounding rounds a decimal value to the specified precision using the specified rounding strategy. And there are 3 or 4, possibly 5, midpoint rounding strategies. So the options are away from 0, and that's what I will call normal rounding up. So 2.355 becomes 2.36, but equally minus 2.355 becomes minus 2.36. Instead of away from 0, we could have 2 even, and that uses bankers rounding. We could also use 2 0. This is the kind of opposite from away from 0. So positive and negatives round towards 0. So 2.355 becomes 2.35, and minus 2.355 becomes minus 2.35. And then we've got 2 other options. To positive infinity rounds towards a positive infinity, so 2.355 becomes 2.36, and minus 2.355 becomes minus 2.35. So notice here that's going towards 0. Yes, it's going towards 0, but it's going towards positive infinity. And lastly, to negative infinity, so positive and negative round towards minus infinity. So 2.355 becomes 2.35, but minus 2.355 becomes minus 2.36. Now from this we can see that what we need, or what I want, is midpoint rounding away from 0. And hence our rounding here, midpoint rounding away from 0 in all cases. I may have gone a bit overboard. I'm rounding it to 3 decimal places. In fact, I probably only need it to 2, but that's a different story. Note that it is only when carrying out a division that there is any need to do any rounding. And on another note, why am I using decimal.round and not math.round? As far as I can find out, there is basically no difference between the two. I just happened to alight on decimal round first. And it also seems that I could have written decimal round with a capital D. Again, I don't think that makes any difference. So having got the method, we just need to add it. And we're going to add it to the will save method. So let me put the command I want in wall save. I'm going to change back to 150%. And we always want to do this calculation on a wall save. So the code we want is just await calculate area, and then we're passing into it the wall add edit object. That should be it for the wall calculation. So let's run the application and test that it works. Well, that wasn't supposed to happen. The eagle-eyed amongst you may have noticed that I had some errors down here that I hadn't spotted. On looking at the problem, it seemed that off screen, on one of my rounding lines, I got some spurious characters at the end of the row. This doesn't affect any of the description that I gave, but it's a bit annoying nonetheless. Anyway, let's give it one more go and check that it works. The good news is that it runs. So let's try adding a wall and seeing if we get an area. I'm going to delete the ones we've already got, so I start off with a clean sheet. So I'll add a simple wall first. So simple numbers, it's 3 meters by 2 meters, so it should be 6 square meters. And we've got 6 square meters here. If I add a complex one, I'm going to make these numbers up. Let's make it 4,000. I think those should give us some numbers worth looking at. If I click save, and I get an area of 8.3. I'll check the calculation, but I'm pretty sure that's okay. So that works. The final piece of the jigsaw is to put in some deductions for where walls have things like doors and windows. And that's going to be in the next video. I'll put links in the description to any resources that I think could be helpful. I'll also put a link in to the blog post for this video and to a web page with the full code. Thank you very much for watching.